Hello everyone, today we're going to look at using the normal curve. So the book talks about using a TI-83 or 84 calculator. Most people don't have those. Here we're going to talk about using the standard normal table, and then in another video I'm going to talk about using Excel. So the standard normal tables typically come in pairs. One will show values if z is negative, and the other will show values of z if z is positive. They show probabilities of the form probability of z less than or equal to z. Occasionally you'll come across a table where it's the probability between 0 and z, so between 0 and 0.5 or between 0 and 1.3, but most of them are in the form that we have listed here. So we're going to assume that we're looking at one of these tables. Remember that since the standard normal distribution, or really any normal distribution, whether or not it's standard, is a continuous distribution, so the use of the equal sign doesn't matter. The probability of z being less than or equal to z is the same as the probability of z being less than z. So whether or not there's an equal sign isn't going to make a difference. Throughout this video, we're going to be using the standard normal tables that you have available on our learning management system. As of right now, it's Canvas. It might be something else depending on when I'm teaching this class again, but for now it's Canvas. So here's a section of the positive valued standard normal table. So how we read this is our z values are on the outsides of the table. So we start looking at our columns. Z is 0.1, 0.2, 0.0, I skipped that one, 0.3, and it'll keep going. And it usually typically goes up to 3 point something. So those are our ones and tenths place of our z's, and then at the top are our hundredths place. So 0.00, 0.01, 0.02. So that if I looked at, for instance, this number here, that corresponds to a z of 0.32. So 0.3 is over here, 0.02 is right here. Okay, so you read the ones and tenths place on the column, the hundredths place on the row. So that's how we typically look at it. And then again, remember that this is showing us the probability that z, capital Z, is less than or equal to our little z. So if I wanted the probability that z is less than or equal to 0.14, I will go down my columns until I get to 0.1, and then I will move over my rows until I get to 0.04, so that together it is 0.14, and that will give me this guy right here. So the probability that z is less than or equal to 0.14 is 0.5557. If I wanted the probability that z is less than or equal to 0.07, I go to 0.0 and then 0.07. And that will give me this guy right here. So 0.5279. If I want the probability that z is less than 0.33, I will go to 0.3 and then 0.03 to get 0.33, and that gives me 0.6293. If I want the probability that z is greater than a value or greater than or equal to, we need to use the complements, just like we did in Excel with the binomial or the Poisson distributions. I need to rewrite this so that it looks like a probability of z less than or equal to. So I'm going to rewrite it as 1 minus the probability that z is less than 0.26. So I go to 0.26, so 0.2, 0.06, that gives me this guy right here, 0.6026, and I plug that in. So 1 minus 0.6026 gives me a probability of 0.3974. So we'll do another one. Probability that z is greater than 0.35. So again, it's set up as greater than, which we don't like, we can't use that. So we rewrite it using less than. So the probability that z is greater than 0.35 is 1 minus the probability that z is less than or equal to 0.35. So I go to my table, I find 0.35, 0.3, 0.05, and we're going to be using 0.6368 in our equation. And that gives us a probability of 0.3632. Other types of probabilities we can have are the probability that z is between two values. We still need to use complements, even though we have the symbols less than and less than or equal to, but we have them in between two values. So I'm going to first just look at what it looks like graphically. If I wanted the probability of z being between a and b, then graphically, that is this guy over here. And if I want to write it in terms of less than or equal to, I can think of it as this minus this. So if I take that big red one here, subtract what's in blue, which is this guy right here, I will get exactly what I have over here. So just like with binomial and Poisson, if I have the probability between two numbers, I'm going to be taking a probability minusing a probability. So I get it's the probability that z is less than b minus the probability that z is less than or equal to a. So for example, find the probability that z is between negative 0.5 and 1.2. So that's going to be the probability that z is less than 1.2 minus the probability that z is less than or equal to negative 0.5. So neither of these numbers are on the part of the table that I was just showing you. So I really want you to take out the tables themselves and make sure that you can find the numbers that I'm putting in here. So we're going to use both tables for this one. The first one is the positive table. The second one is going to be the negative tables. Okay, so again, if you haven't already, pause the video now and bring up the two tables to make sure that you're getting the same numbers. So you should be getting 0.8849 for probability that z is less than 1.2, and 0.3085 for our second probability. Notice that when z is positive, all of our probabilities are at least 0.5 because you're looking at more than half of the table. And if z is negative, then your answers are less than 0.5. And if I do that subtraction, I should be getting 0.5764. So let's try another one. What's the probability that z is between 0.32 and 0.76? So both of these numbers are positive, so we're going to be looking at the positive part of our table. And again, we're going to have the probability that z is less than 0.76 minus the probability that z is less than or equal to 0.32. Hopefully you're getting 0.7764 for the first one and 0.6255 for the second one. Again, they're both positive, so they're both going to be bigger than 0.5. And when I do the subtraction, I get 0.1509. What if we want to find a percentile? So for an example, let's find the 60th percentile of the standard normal distribution. Remember, a percentile is the value of z such that 60% of the values are less than or equal to z. So we're really going backwards here. We're finding z such that the probability of capital Z being less than or equal to z is 0.6. So the 0.6 that we're looking for is a number that's inside the table. So I have here again the little part of the table that we had. So we're going to look for 0.6 inside the table. And they're always going to be going in a certain type of order. So if you look at the first column, these numbers are getting larger. They're getting larger. They're getting larger. They're always going to get larger as you go from left to right if you're looking at the positive one. And you want to find the number that's closest to 0.6. You might not have exactly 0.6, but you're just going to look for whichever one is closest. And that is the one that I have in red here, 0.5987. The next one is 0.6026, but the one that's in red is closer to 0.6. And then when we find that number, we look for the corresponding z value. So it's going to end in point something 5, and it's going to start with 0.2. So the 60th percentile is 0.25. Remember, the positive ones are all bigger than 0.5 in the probabilities, and the negative z-table are the ones that have probabilities from 0 to 0.5. So the fact that 0.6 is bigger than 0.5, I knew to look at the positive z-table. So for the rest of these examples, again, I'm going to assume that you have the table in front of you, and I want to make sure that you're checking it. You're finding the numbers that I'm going to be using. So find the following percentiles using the standard normal table. I want to find the 10th percentile. So 10% is less than 50%, so that I know already that it's going to be a negative value. So I go to my negative table, and I look for the closest that I can find to 0.1000. And then I go and look at the ones in tenths column, and then the hundredths row. I think I switched those, you know what I mean. So it should be negative 1.28. So I went down, so wherever my point closest to 0.1000 was in the negative 1.2 column and the 0.08 row. So I get negative 1.28. What about the 25th percentile? So again, 25% is less than 50%, so I know my answer is going to be negative. So if I find the closest value I can to 0.2500, I should be getting negative 0.67. So again, that's negative 0.6 for the column, 0.07 for the row. No, I did write that backwards. The row is the ones and the tenths, and the column is the hundredths. I don't know why I'm getting confused right now. So the row corresponding to negative 0.6, and the column corresponding to 0.07. Again, make sure you're in the negatives because 25% is less than 50%. Let's see if I can do this one without messing up. 80th percentile. 80% is more than 50%. So I know my answer is going to be positive, so I go to the positive table. In the middle, look for whatever is closest to 0.8000, and hopefully we will find the row corresponding to that is 0.8, so 0.8, and the column is 0.04. And that will give us a value of 0.84. The last thing we want to do with the standard normal curve is find something that looks like z sub alpha. So that's the Greek letter alpha. We're going to see this come up a lot in later chapters, so this is going to come up again. Z sub alpha is the z value such that the area to the right of it is alpha. So this is like the opposite of a percentile. We're looking for z such that the probability of big Z being greater than or equal to little z is alpha. So alpha is a percentage. You can think of it as 0.25, 0.85, 0.04. Okay, so alpha is somewhere between 0 and 1. And then z sub alpha is again a z value, and it's the opposite of a percentile. So pictorially, this is what it looks like. Again, the area to the right is alpha. So to find z sub alpha, what we really need is 1 minus alpha. We need the probability or the area to the left of that value. Because again, everything is in terms of the probability of z being less than or equal to some value. So let's do a couple examples. Find z sub 0.25. So this is the same as the 75th percentile. So again, we're looking at 1 minus alpha. So 1 minus 0.25 is 0.75. So it's the 75th percentile. 75% is bigger than 50%. So we're going to go into our positive table and look for 0.7500, whatever is closest to that guy. And hopefully you're getting 0.67. For the next one, we have z sub 0.90. So again, what we want is 1 minus alpha, which is 0.1, which is the 10th percentile, which we actually did before. So we should still be getting negative 1.28, just like we did last time. The last one is z sub 0.99. So alpha is 0.99, but again, the number that we need is 1 minus alpha, which is the first percentile. Again, 1% is way less than 50%, so we know that it's going to be a negative number. So again, you want to look for 0.01, the number that's closest to that, and we should be getting negative 2.33. What if we don't have the standard normal curve? So if we just have a normal curve, so for instance, x is normally distributed with mean 200 and standard deviation of 15, how can we use the standard normal table to find values? So what we're going to have to do is we're going to have to standardize our values and then use the table. So for instance, if I want the probability that x is less than 160, I need to find the z value associated with 160. So remember, the equation is that z is x minus mu over sigma. So I want 160 minus 200 divided by 15. And that's going to give me negative 2.67. So remember, the table only goes to the hundredths, so you want to round everything to the nearest hundredths place. So the probability that x is less than 160 is the same as the probability that z, the standard normal curve, is less than negative 2.67. Then I'm going to use that number in the table, and hopefully we get 0.0038. What about the probability that x is greater than 190? So again, I'm going to have to standardize the 190. So I take 190 minus 200, divide by 15, and I get two decimal places, negative 0.67. So the probability that x is greater than 190 is the probability that z is greater than negative 0.67. The fact that I have greater than means that I'm going to have to take 1 minus the probability that z is less than negative 0.67. So if I look up negative 0.67 in the table, I get 0.2514. So I need 1 minus that, because again, what I want is greater than. And that will give me 0.7486. If I want the probability that x is between two values, again, the first thing I have to do is standardize them. So if I standardize 200, I'm going to get 0 because 200 is the mean. And if I standardize 230, I'm going to get 2. So the probability that x is between 200 and 230 is the same as the probability that z is between 0 and 2. If I look at 2 in my table, I'm getting 0.9772, and if I look at 0, I'm getting 0.5. Okay, so remember, it's the probability of z less than or equal to 2 minus the probability that z is less than or equal to 0. Remember, 0 is the mean, it's also the median, so it's splitting it up 50-50. So if I do the subtraction, I get 0.4772. What if I want to find a percentile? So if I'm looking for an x value, I first find the z value and then change it back to an x. So I look at the negative z table because 20% is less than 50%, and I find that z is negative 0.84. So to find x, I'm going to plug it into the equation that we had before solving for x. So if z was x minus mu over sigma, x must be z sigma plus mu. I know z, I know sigma, I know mu, so I plug them all in, and I get 187.4. Remember, the 20th percentile has to be smaller than the mean, so my answer at least makes sense. It's smaller than the 200. And then the last one is x sub 0.45. So remember, this z sub alpha, this x sub alpha, what I'm really looking for is 1 minus alpha. So x sub 0.45 is the same as the 55th percentile, 1 minus 0.45. And again, I'm going to find the z value on the table. 55% is bigger than 50, so I'm looking at the positive table, and I'm getting hopefully 0.13. So I'm going to plug that into our equation again to change it from a z value to an x value. So x is going to be 0.13 times 15 plus 200. That's going to give me 201.95. So the fact that it's 55 percentile means it's above the mean, and that's fairly close to the 50th percentile, so our number shouldn't be too much bigger than the mean. So 201.95 is fairly close to our mean of 200. So again, hopefully it makes sense. Okay, so play around with this, and then again, watch the video on how to use Excel for it also. Let me know if you have any questions.